unit impulse function or unit sample function delta n. The unit impulse function delta n is defined as the sequence with values delta n which is equal to 1 if n is equal to 0, 0 if n not equal to 0. Now we'll see the z transformation of unit impulse function. Now z of delta n, z of unit impulse function, right, is equal to summation n is equal to 0 to infinite delta n z power minus n from the definition of z transformation, right. So when n equal to 0, so put n equal to 0, you will get 1. Then remaining all are 0. For n not equal to 0, delta n equal to 0. So 1, that is equal to 1 plus 0 plus 0, etc. etc. So z of delta unit power minus n from the definition of z transformation. So when n is equal to 0 to infinite, the un value is equal to 1. So replace the un is equal to 1 into z power minus n can be written as 1 by z power n. That is equal to summation n is equal to 0 to infinite 1 by z power n. So substituting the value of z and taking the summation 1 plus 1 by z plus 1 by z square plus etc. etc. So we know 1 plus x square etc. etc. is equal to 1 minus x power minus 1. Here in the place of x you are having 1 by z, so you will get 1 minus 1 by z power minus 1. Taking LCM z minus 1 by z power minus 1. So again you are taking the reciprocal because you are having z minus 1 by z power minus 1 can be written as z by z minus 1. Therefore z of un is equal to z by z minus 1. Next, exponential function e power n. The exponential function is defined e power n is equal to f of n is equal to e power minus a n t for n greater than or equal to 0, 0 n is less than 0. Now we'll see the z transformation of exponential function. Now z of e power n which is equal to z of f of n is equal to summation n is equal to 0 to infinite f of n z power minus n. Replace f of n by e power minus a n t. So you will get summation n is equal to 0 to infinite e power minus a n t z power minus n, right, that is equal to summation n is equal to 0 to infinite e power minus a t. So e power minus a n t can be written as e power minus a t power n, because if you are having a power 2 into 3, then it can be written as a square whole cube or a cube whole square, right, same idea. A power m into n can be written as a power m power n. So e power minus a t power n, then z power minus n can be written as z power minus 1 into n. So again this can be written as z power minus 1 power n. Grouping these two, so summation n is equal to 0 to infinite e power minus a t z power minus n whole power n. So substituting the value of n, so you will get 1 plus e power minus a t z power minus 1 plus e power minus a t z power minus 1 square plus etc. etc. We know 1 plus x square etc. etc. is 1 minus x power minus 1. Here in the place of x you are having e power minus a t z power minus 1. So you will get 1 minus e power minus a t z power minus 1 whole power minus 1, right. So this can be written as 1 by, because a power minus 1 is equal to 1 by a. So 1 by 1 minus e power minus a t into z power minus 1. So that is equal to 1 by 1 minus z power minus 1 can be written as 1 by z. So you will get e power minus a t by z. Taking LCM in the denominator 1 by z minus e power minus a t by z. So this is nothing but z by z minus e power minus a t, right. Thanks. We'll see you in the next video.